So you want to quickly kind of get a grasp on your times tables. Well, let's go ahead and do that. Let's do a kind of a quick session here, or at least as quick as I can do. We're going to be covering today the numbers 1 through 12, the rules. Let's just go over the ones you probably already do know. 0. This is divisibility rules. So with 0, you can't divide by 0. Only in clock math you can do that. For example, at 12 o'clock, 12 o'clock equals 0. So 24 hours can be divided by 0 in this system because it equals 2 or something like that. So only in situations like that, or basically speaking, you divide by 0. 1, everything divided by 1 is itself. Let's see. Yeah, so let's just go ahead and start with 2 now. I'm not really going to go in order of the numbers, but 2 is a good place to start off with learning the general pattern of how to find divisibility rules. Because we're not just going to learn the divisibility rules, we're also going to talk about the idea behind them. So this one's, of course, also pretty easy. You take any number in the world you want, like 726. You look at the last number. If it's even, then you can divide by 2. So that's a pretty easy rule to follow. However, I'm going to give a slightly different rule too, and this is important because it's going to build a pattern for a lot of the stuff we're about to talk about. So with this one, let's try the same one, 726, right? In fact, let's do something easier. How about 646, okay? And what I want you to do is I just want you to divide by 2. If you can divide by 2 evenly, sorry, that's subtraction. If you can divide by 2 evenly, then, in other words, it's not odd, then you can do that. So, the rules, now I'm going to skip 3. So we're going to skip 3 here. We're going to the rule for 4. So I'm going to have to cross out for a second. We're going to go straight to 4 for a reason. So, as you may have learned in school, 2 squared is 4, or 2 times 2 equals 4. Alright, and this is important because we're going to take some other number, let's say 100, okay? And our rule here, we can have 2 different rules that goes on here. We can take, if the last 2 digits are a number, we just focus on the last 2. So it doesn't matter if it's 586,432, something like that. We just worry about the last 2 digits only. If those numbers are divisible by 4, then it's divisible by 4. So in this case, 100, yes, 100 is divisible by 4. So you basically have to be familiar with all the numbers from 1 to 100, whether or not they're divisible by 4. 84 is divisible by 4. So 0 just stands for 10 or 100. 10 here, 100 here. Alright, so obviously 0 is not what we're counting in this. So that is the main way to look at it, is the last 2 digits. But another way I want you to look at, and this is what I meant earlier, sorry, I confused it with the rule for 2. But this is what I meant earlier about building up the patterns of how all this works. So as I said earlier, it's 2 squared, right? So what was the rule for 2 if it's an even number? Alright, so let's go back to our number 100. Now let's divide that, oops, again, that's not... Okay, let's divide that by 2. We get 50. Now we have to ask ourselves, is 50 an even number? And the answer is yes. Now why did I do that? Because 2 times 2 is 4. So if we take away one of those 2's, we have a 2. Therefore, we can just skip straight to the rule for 2. In other words, we're using rules that already exist to build on new rules. So there's 2 ways, again, there's 2 ways to do a 4. We can look at the last 2 digits of a number, or we could divide it by 2 one time and then ask if it's even. Either way is fine. And so also, we're going to skip 5 and 6 and 7 and go straight to 8. Wait, hold on. And go straight to 8. Because why? Because 8 is 4 times 2. But more importantly, we're going to work with prime numbers here. 2 is a prime number. 2 cubed, or 2 times 2 times 2 equals 8. Now, just like with the rule for 4, we're going to build on that pattern I said earlier. First, the main rule, the traditional rule people talk about, is the last 3 digits. So you can have any number, you know, whatever, as long as it's not infinitely long. Any number that has an end to it going this way. We just take the last 2 numbers, or sorry, the last 3 numbers, my bad. We take the last 3 numbers, and we ask if that number is divisible by 8. And if the answer is yes, then it's divisible by 8. For example, we can take the number 400. Is 400 divisible by 8? Yes. So, if this number was 32, 400, then yes, this number is divisible by 8, because the last 3 numbers are. However, I find this rule a little bit problematic, simply because I don't know all the numbers are divisible by 8 all the way up to 100. I could easily calculate that, but that's still more mental math. So I prefer to use the 222 method. It's just like what we did with 4, but one extra step. So let's take the number 400 and divide it by 2. It's 200. And then we divide that by 2, and it equals 100. And we ask if this third one is it divisible by 2, or sorry, is it even? Sorry, we ask if this one right here, if this is even. And yes, it's even. So therefore it's divisible by 8, because remember, it's 2 times 2 times 2. So in this situation right here, we got rid of one of these 2's. Okay? And then in this situation right here, we got rid of this other 2, leaving us with 100. So we just follow the rule for 2 for that 100. And that's how that works. Okay. So, again, what we're using is prime numbers that make other numbers to build up new rules. This is going to be important. Very, very important. This is going to be a big key to how we do a lot of this, the rest of the stuff here. So, again, you can just remember the last 3 digits. But I prefer, because some of those just take a little extra work for me mentally, I just prefer dividing by 2 twice. So do it one time, do it a second time, and then is your last number even after the second time. If it's even, then you're good to go. It's divisible by 8. All right, now let's do the 3 rule, because we're going to use the 2 and the 3 rule to make the 6 rule, just so you know. Now the 3 rule and the 9 rule, let's just do these together. Oops, 9 doesn't go there, 9 goes here. Okay? The 3 rule and the 9 rule, we're going to do these together because they're the same thing. If a number, if you add them together, add the digits together, and they equal 3 or 9, then they're divisible by 3 or 9. For example, 3 plus 6 is 9, plus 9 equals 18. All right? Both 3 and 9 go into 18, so therefore it's divisible by both 3 and 9. So, straightforward rule, just add the digits together, and if it's divisible by 3, then it's divisible by 3. Divisible by 9, then divisible by 9. Which means every number that's divisible by 9 is divisible by 3. It should make sense, because 9 is just 3 squared. But not every number divisible by 3 is divisible by 9. For example, 33. 3 goes into that, but 9 does not. Alright. So that one's also pretty familiar. A lot of people do know that, but maybe some, just in case some people didn't. Now let's make the rule for 6. Okay, the rule for 6 is to combine these 2 rules together. Remember, both these numbers are prime, so we can make a good, decent rule out of it. Oops. Okay, so the rule for 6 is to just do both of those rules at the same time. If a number, let's take, we could even construct it. 8, let's see, we want to get the number 12. So 8 plus 1 plus 3, that makes 12. Ooh, but we want an even number. So 8 plus 2 plus 2. So that's 4, so that makes 12, okay? So these numbers added together equal 12. 12 is divisible by 3, so that checks out. And the rule for even numbers or for 2 is an even number. So 3 times 2 equals 6. It passes this rule and this rule, so it's divisible by 6. And that's all you need to know. Does it pass both rules at the same time? If it only passes the 3 rule but not the 2 rule, then it doesn't pass the 6 rule. If it passes the 2 rule but not the 3 rule, then it doesn't pass the 6 rule. It has to be both before it can be divisible by 6. Alright? Let's do some easy ones now. Let's do 5. this one you probably also learned very well in school. Any number that ends in a 0 is, except for 0, is divisible by 5. Any number that ends in a 5 as the last number. Okay, so we have numbers here. That is also divisible by 5. That one you probably already know. So 5 or 0, divisible by 5. Now, we can also do 10. Let's just knock 10 out the way. 10 is 2 times 5. So we could just do the easy way and just say any number that ends in a 0 other than 0 is divisible by 10. In fact, as many zeros as there are at the end is how many 10s that fit in there. That's really all you need to do. But again, technically speaking, it's the two prime numbers 2 times 5. So anytime you have a 2 and a 5 you can pair together, you get a 10. That easy. But anyway, we just look for the zeros in this case. Alright, so now we have almost done here. We have 11 and 12 and 7 left. 7 is the hardest. We'll do that one last. We'll do 12 now. 12 is... Let's take our primes out. So it's 4 times 3. But of course, or 6 times 2. So there's a lot of ways we can technically do it, but let's just work with primes. So we just work with 2 times 2 times 3. In other words, it has to obey the 3 rule, and to make this simple, it has to obey the 4 rule. So again, that's not really all that much of a stretch. If we have a number that adds up to... So let's take the number 204. Is that divisible by 12? Let's check. Let's add the digits together. They equal 6. So it passes our 3 rule. Now let's make it pass our 4 rule. I don't know if 204 is divisible by 4. Actually, yes, I do, because 100 is. So 100 plus 100, those cancel out. We have 4 left over. 4 is divisible by 4, so yes. I could look at it that way, or if I wanted to, I can just do the one I said before. Okay, so half of 204 is 102. And then half of that is 61. Sorry, that was totally wrong. I meant to say 51. Oh yeah, sorry, that's the rule for 8. So it's not divisible by 8. We only have to divide by 2 one time. And 102 is even. So it passes our 4 rule. So it passes the 3 rule and passes the 4 rule. As we just seen, though, it wouldn't pass the 8 rule. It's definitely not divisible by 8, we just found out. But that's also not our concern. So, again, if it passes the 4 rule and the 3 rule, we're fine. Alright, so that leaves us with 7 and 11. 7, 11. Alright. The 11th rule isn't too bad. It's just a little strange. So the 11th rule is anything that's divisible by 11 or 0. Or it's either 0 or divisible by 11. So let's take, for example, 141. Now this one definitely looks like it's divisible by 11, but let's just check. Okay, the first thing you want to do is minus and then plus. Alright, so you take away 3, that equals negative 3, plus 1 is negative 2. Oh, that one's not divisible by 11. Let's take the number 231. Alright, so 2 minus 3 plus 1. 2 minus 3 equals negative 1, plus 1 equals 0. So that's right there, there's our 0. So this one is divisible by 11. So basically the rules, it doesn't matter how many numbers you have. You subtract the first one from the second. So subtract, add, subtract, add, subtract, add. Wait, sorry. Got tongue twisted there. Subtract, add, etc. And if that final number, after you did that with all the digits, equals 11, a number that is divisible by 11, or 0, then you are good to go. That number is divisible by 11. So that's pretty cool. It's similar to the 9's rule and the 3's rule, just a little different. Instead of adding the whole time, you're alternating which one you're doing. Now here comes the 7's rule. The 7's rule is the little bit the most trickiest and might actually be something you might need pencil and paper for, even if you're good at mental math, but we'll see. Alright, the 7's rule is you take any number you want and you break off that last digit, and this becomes a new number. And this becomes a new number. So you're just breaking that off from your old number. Let me show you how that works. You can start off with a number like 168 here. It's not obvious whether or not it's divisible by 7. So let's break off. In fact, let's just literally just do this. Let's break off that 8 and multiply it by 5. And that equals 40. Alright? So 40, and then we add our old number, or our new old number, and we add that to our number here, and so that equals 56. Is 7 divisible by, or sorry, is 56 divisible by 7? Oops. And the answer is yes. That is true, or a subset of. So that is definitely true. 56 is a multiple of 7. All right, how about 2359? Oops, 2359. All right, so then we do the same thing. We take our 9, we just break it off, and then multiply it by 5. And then, of course, 9 times 5 is 45. Okay. And then we take 235, and then we add 45, 10, so that's 8, and it's 2. All right, but that doesn't really help us too much now, does it? I don't know about 280. Is 280 divisible by 7? I'm not quite sure. Well, that's okay. You could do it again. So we take 280, we break off the 0, multiply it by 5, which is still 0. So now we just ask if 28 is divisible by 7. And of course, 28 is divisible by 7. So this, is divisible by 7. All right? So basically speaking, and this is another reason why I said you might need pencil and paper for this one, regardless, because you might have to do it again and again. Sometimes these numbers are a little bit long, and you just have to repeat the process. That's okay. As long as eventually you get to some number that's divisible by 7, eventually, then you know the original number is also divisible by 7. Okay? As long as it eventually gets there. It's also the converse is true as well. These kind of things are not always opposite is true, but in this case it is. Oh yeah, I'm writing this backwards. But anyway, so if your number does not equal, or is not divisible by 7, then that one, your starting number, is not divisible by 7. So it works in reverse. It works both ways. And again, you can keep doing as many times as you need to get there. And it's going to be true both back and forth. It's true both ways. So that's really cool and satisfying to know. It's a very complete rule. Even though it's a little strange. Kind of curious how one person gets there. And so that's our rules for 1 through 12. Of course, if you wanted to, you could combine some of these rules and make some new ones for yourself. For example, if you wanted to, you could combine the rule for 7 and, I don't know, the rule for 3. Of course, that equals 21. So now you have a rule for whether something's divisible by 21. So we can have 252. All right, so this makes 7 and this makes 9. So it passes the 3 rule. And then let's do 25. 2 times 5 equals 10. Plus 10 equals 35. That one passes our 7 rule. So that means this whole number here, 252, is also divisible by 21. So you can, again, use your prime numbers on the list. Sometimes you can use non-prime numbers, I think. I just, for the safe side, just use the primes. And, I erased everything. And you can come up with new rules as well for other kinds of numbers. Basically, does it follow all the rules of the other ones at the same time? If it does, you're good to go. All right. This is Jordan Reed, signing out.